So in this video, I'm going to discuss about the next category or the second category of the shift register. So in the previous lecture or in the previous video, I've already discussed about the first category, that is serial in, serial out. Now, in this video, I'm going to discuss about the next category, that is known as uh, serial in, parallel out. Okay, this category I'm going to discuss. Okay. Now, what is serial in, parallel out shift register? So you have to give the data serially, and you have to give the data serially in this input terminal, and you'll be getting the output parallelly in these four terminals for this particular configuration. Okay, so in this configuration, we have used 4 flip-flops. Okay, so 4 data or 4 bits you'll be collecting in these 4 output terminals. Okay, now in this case, we can take one example. Suppose we are considering the example of 1111. These 4 data or 4 bits we are giving as an input. Okay, and we will be observing whether we are getting this 4 data in these output terminals or not. So initially we can consider these flip-flops are having reset state, means all the outputs are 0. Outputs are 0 means Q0 is 0, Q1 is 0, Q2 is 0, Q3 is 0. So all these 4 outputs we are considering 0, and we are applying the first bit of data, that is LSB, in the input terminal of this shift register. Okay, this is the input, and we are applying the first clock. Okay, now you'll see what output you are getting. So as your input is 1, okay, let me write down till now what values I am having, then it will be easy for you to understand. So till now, these are my values I am having. This 0, because I am considering all the initial outputs are 0 or all the flip-flops are in reset state. And at that time I have given the input of 1 here, and I have applied the clock. So after applying the clock, what you will get? I'm using black color to show that. So as your input is 1, here you will get the output of 1. This one you will get. As your input is 0 in this stage or stage number 2 or flip-flop number 2, you will get the output of 0 here. As your input is 0 in the third stage, you will get the output of 0 here. As your input is 0 for the fourth stage, you are getting the output of 0 here. Okay. So after the first clock, what output you are getting? That is 1, 0, 0, 0. But what was my data? That is 1, 1, 1, 1. So till now I didn't get this entire pattern, whatever I have applied here. Till now I got only a single one. I need to get all the 4 ones. Okay. So how to get that? I need to apply clock 4 times. So till now I have applied only one clock. Now I need to apply the clock for the second time, and I need to input the second bit. So let me show you. So this is the second bit I have applied here in the input terminal, and I am applying the clock. So if you can remember what was the previous stage output, let me write down here. This 1, 0, 0, 0. So let me write down here by using red color. Then it will be easy for you to understand the previous stage output. I can write it here that you got 1, here 0, here 0, here 0. Now, in this case, in this current case, means after applying the second clock. In the first stage, you are inputting the value of 1. Meaning the first flip-flop, you are inputting the value of 1. Why? Because what data I have given, that is 1, 1, 1, 1. So that first LSB was applied in the previous stage. Now the second one you are applying here in this stage. Okay. So your input is 1. It means your output will also be 1. As your input is 1 for the second stage, your output will be 1. And for the third stage, it will be 0 as your input was 0. And for the next stage, the output will be 0. Okay, as your input is 0. So these are the outputs we got in this stage, or means after applying the second clock. So these values I am writing. Next time I have to use these values. So let me write down this 1, this 1, this 0, this 0. Now I need to input the third one. Okay. I need to input the third one. So I am inputting the third one here and I am applying the third clock for the third time. Okay. Okay. So what will happen as you have inputted 1, you will get 1 here. So let me use the black color again. This one you will get. This one you will get in the second stage. This one you will get the third stage. This 0 you will get in the third stage. Okay. So what does it mean? After applying the third clock, you are having this output of 1, 1, 1 and it is 0. So it means still you didn't get the entire thing. You didn't get 1, 1, 1, 1. Okay. Now what I need to do? I need to apply the fourth input or MSB input and I need to apply the clock for the fourth time. So I have applied this input and I am applying the fourth clock. But before that, just let me write down the values we have obtained in the previous stage. So that is 1. Then this is 1, this is 1, 0. Okay. Now we can discuss about this current stage. So I'm applying the clock for the fourth time. My input is 1. What output I will get here is 1. And from here I will get the output of 1 as your previous input is 1. The previous output was 1. So I will get the output of 1 here. And in this stage, the input is 1. I will get the output of 1. So you see after applying the fourth clock, you are having all the bits whatever you have applied in the input. Okay, so this is the principle of serial in parallel route. So what does it mean? If you have 4 flip-flops, you need to use at least 4 clock to get the bit pattern whatever you have applied in the input serially. Okay, so if you have n number of flip-flops, you have to use n number of clocks to get this particular pattern whatever you have applied. Means if the pattern is also having n number of bits, then you will have to use n number of clocks to get this entire combination in the output of this shift register in this special category, that is serial in parallel out. Okay. Now come to the next category, that is parallel in parallel out. So parallel in parallel out is the simplest one. You need to input this particular bit pattern. Suppose, for example, I can take the example of 1010 bit pattern. Okay, so 1010 I am applying in these 4 terminals of this parallel in parallel out shift register. So these are the parallel input and these are the parallel outputs. So in this case, what will happen? Simultaneously, you will get all the bits in the output and simultaneously you are applying all the bits in the input. Okay, so it means in a single clock cycle, you will get all the outputs. Means all the bits you will get in the output in a single clock cycle. Okay. So if you apply 1010, what does it mean? As in the D flip flop, you are applying 1, you'll be getting 1 here. As you have applied 0, you'll be getting 0 here. As you are applying 1, you'll be getting here. As you have applied 0, you'll be getting 0. Means after applying the first clock. This well known to everyone. Okay. After applying the first clock, this one you will get here. This 0 you will get here. This one will get here. This 0 will get here in the out. This is the principle of D flip flop. Okay. So this is the working principle of parallel in parallel out. Okay. I think this will be clear to everyone. Thank you.